compression, like you have to code like something like the compressed code of length m and like the original code of length n, and then like the weight is fixed. So n goes to infinity level, m goes to infinity also. What's the big deal? I mean,
but they can prove even if m goes to infinity, m will still stay in the left-hand side, the right-hand side.
But the right-hand side, okay. So you mean the right-hand side will go to infinity faster than n?
Yeah.
Okay.
I think so.
Another question for again the third part. How we know about the J?
The third part?
Yes.
Just suppose decoder knows the information. We suppose decoder knows in this case, in this assumption, we can calculate it.
It means in all of the cases only one certain set is fired and certain columns is selected to find the original signal. It's not changed.
You can consider as there are another channel. They have an limited communication between decoder and encoder. They can send the information about J to decoder.
Okay.
Without using the total bits.
Okay. Maybe the first of the communication sets, this part is for this set is fire and
Yeah.
Okay.
In this setup,
Okay.
we will have this assumption. Here is a SNR, here is a beta, and we can see beta is always larger than any complex.
Your beta is defined C2 to the 2R somewhere. Yeah. But then it would be the other way one. Right?
Yeah.
Delta is less than 1.
Yeah.
So delta is less than 1. Shouldn't it be the other way one? Beta is like 2 to the minus 2R, right? Then it should be less than like 2 to the minus 2 delta R, right? When delta is less than 1. You have the exponent is less, is bigger, more negative for beta. Yeah, so isn't that it should be smaller?
Yeah, I think that should be smaller, but this paper said.
Okay. Yeah, okay. How? What's the conclusion? I mean,
The conclusion is you cannot quantize this is
so is that like saying like basically CS is trash if whenever you do condensation, kind of like you cannot.
yes, if you given the total basis k times r, because k is the freedom degree of the signal. If you do the rate allocation according to the number of freedom of the signal,
J, for example, like J.
Not J.
Oh, I mean the order of J instead of order of K. Yeah, no. I mean, if your weight increases, like not of the order of K, but like of order of J, then you'll be fine, something like that.
Oh yeah. If you make a rate on occasion according to the number of freedom K, and when n goes to infinity, then CS cannot recover anything. This is the conclusion. So they introduce a compressive sensing, the distributed source coding to solve this problem. So actually,
so when they use distributed source coding, it's possible to increase rate just KR?
Yeah, use the same rate KR, because right now the total rate is the entropy of QYI. The rate is depends on the context value of QY. If you use the distributed source coding, the total rate is the QY1.
Okay.
This means the total rate for compressed YI here is the for each YI. If you consider the compressed sensing and the distributed source coding problem, then the total rate is here. So given the K times the R, this needs much less bit compressed by I. So you can use the remainder to compress to represent more information about Y. You have more bits to compress by.
And then like we can like have weight just proportional to K.
Yeah, because in this case the penalty is a constant. In this case, the rate distortion is this one is not constant. This depends on it. And in this case, the distortion is a constant. So it's the independent operator.
Say that again. Which one is which again?
In this case,
this case is what case?
The fourth scenario.
The first one, without DIC.
Yeah, without DIC.
Okay.
Yeah, we need this total bits to comprise the And this introduce some.
What's the error is?
Yeah, it's just some error because the computation error and because the estimation error. Because in this case, they have two errors. The first one is the computation error. The second one is the estimation error. If you estimate the J hat is not equal to the J true.
So the error is estimation error.
Yeah.
Okay.
In this case,
The error is the proportional to n. So your rate, your distortion is
Okay.
R if
Okay.
n goes to infinity. But in this case, the error is independent of n. You can use more bit to compile the yi and then use very
little number of bits should compress the context result. Because you take into the information of all the context.
And what is v here? X equal to v.
Yeah, this is a matrix. Just project the x from.
Yes, the how to generate this.
You can. Yeah, you can consider as a Liouville transform.
Is there any default or any work on v that shows the property of the v? For example, which is the property of the v in source coding?
Say that again.
What's the property of v in source coding? For example,
I guess it's just orthogonal. It's okay. It's
Yeah, it's
orthogonal.
how to
like-
find this?
It's just some. Yeah, if orthogonal, you're random. Random will be orthogonal also. Possibly. But it's just you have the all the. Yeah, but I'm not sure if sparse is okay. Like for example, can we be an identity matrix?
So this is WZ. This is compensation for the something off. And you can also use WZ. You can consider something like this.
Yeah, I have.
Yeah, this is means for compressive sensing, each measurement is encoder here. And you can take into account the correlation between each encoder and the drawing source. And send this drawing source to encoder.
Anyone reference to their work that try to implement anything?
No, they said this is just the theoretical image. Yeah, they just to get a theoretical image, and this is no practical scheme to do it. They just propose information theory can do it.
Anyone try? Do you know?
Yeah, there is a reference from MIT, is the master thesis. Yeah, they did some preliminary result about this idea.
Should we try? Up to maybe 2 months later, I don't know. After the proposal need to do that OTC paper, I guess we should. What?
The OTC paper.
The car tracking paper. Yeah, we should submit the car tracking paper.
Oh, yeah.
Yeah, so let's see what else. And some of those media extension.